You want to know what happens when you die. Not the poetry of it, not the comfort of it, not what your grandmother told you or what the priest said at the funeral. You want to know what physics actually says about the whole business. And the answer is stranger and more beautiful than anything anybody has made up about it. Let me start with what you are. Right now, sitting there, you are approximately 7 octillion atoms. 7 followed by 27 zeros. That is a number so large it has essentially no meaning to the human brain. But let us try anyway. If you took every grain of sand on every beach on Earth, and every grain on every planet in the galaxy, you would still not be close to 7 octillion. And all of those atoms that make you up, every single one of them, was forged inside the core of a star that exploded before our sun was even born. You are not just made of star stuff, as the saying goes. You are star stuff that learned to think about itself. And that is only the beginning of the strangeness. Now here is the question that really ought to keep you up at night. What is the relationship between those 7 octillion atoms and the thing you call yourself? Because the atoms do not know they are you. A carbon atom in your liver has no idea it is inside a person. It is just doing what carbon atoms do, which is bonding and reacting and vibrating according to the laws of quantum mechanics. So where does the you come from? Where does the experience of being a person arise from those blind, mechanical processes? That is a question I find genuinely delightful, because I do not know the answer, and nobody does, and any physicist who tells you they do is selling something. But here is what I can tell you. When you ask what happens when you die, the first law of thermodynamics gives you a very clear and emphatic answer. Nothing is lost. Nothing. Not one single electron. Not one single joule of energy. The conservation of energy is not a suggestion or a guideline. It is the deepest thing we know about the universe. Energy cannot be created and it cannot be destroyed. It can only change form. And you, whatever you are made of energy. So in the most fundamental sense that physics can offer, you are not going anywhere. Now I want to be careful here because I am not trying to sneak some kind of mystical survival theory through the back door of thermodynamics. I am not saying your consciousness floats off and joins the cosmos in some warm fuzzy way. I am saying something more interesting than that. I am saying that the matter and energy that constitutes you right now has a history that goes back 13.8 billion years, and it has a future that extends just as far forward. The atoms in your body have been part of countless other things. They have been rocks and oceans and dinosaurs and grass and other people. And after you, there will be other things too. The carbon in your left hand will eventually, over geological time, become part of a tree or a fish or another human being who will look up at the stars and wonder the same things you are wondering now. There is a second law of thermodynamics, and it says something that sounds depressing at first, but turns out to be one of the most profound ideas in all of science. Entropy always increases. Things tend from order toward disorder. And your body is an extraordinarily ordered arrangement of atoms. You are a local pocket of low entropy in a universe that is relentlessly moving toward high entropy. And maintaining that order requires a constant input of energy. You eat food, you breathe, your heart pumps, your cells divide. All of that is the work of fighting entropy, temporarily, locally. And when you die, that fight stops. And the ordered atoms that made you begin to participate in the general trend toward disorder. But here's the beautiful thing about disorder. What looks like disorder from one perspective is just a different kind of order from another. When a sand castle falls apart, the sand does not disappear. It rejoins the beach. And the beach is a perfectly ordered system described by the same laws of physics that describe the sand castle. The sand castle was a more complicated arrangement, sure. But the laws governing each grain of sand are exactly the same before and after. Nothing about the physics changes. Only the configuration changes. Now let me talk about something even stranger. The quantum mechanical view of what you are is deeply weird, and I mean that as the highest possible compliment. At the quantum level, particles do not have definite positions and velocities the way a baseball does. They have wave functions. They are described by probability clouds, by smeared-out distributions of where they might be and how fast they might be moving. And when you measure them, when you interact with them, the wave function does something that we call collapsing. It picks one of the many possible states and goes with it. But the key thing is that before the measurement, before the interaction, all the possibilities are real in some sense. They are all there, superimposed. Now your body is made of these particles. And so are mine. And so is everything. The table, the air, the distant stars. All of it is this vast, shimmering network of quantum fields, interacting and evolving according to rules that are, frankly, absurd to the intuition, but precisely correct to many decimal places when you calculate them. And what I find remarkable is that your body, this local temporary ordering of quantum fields, has enough coherence and stability that it can do something extraordinary. It can model itself. It can think about itself. The universe has arranged itself in such a way that some arrangements of quantum fields are capable of asking what quantum fields are. I find that astonishing. So what happens to those quantum fields when you die? They keep going. Every quantum field pervades all of space. The electron field is everywhere. The quark field is everywhere. The electromagnetic field is everywhere. When you die, the electrons in your body do not vanish. They rejoin the electron field that was always there. They become part of the great ongoing interaction of fields that constitutes the physical universe. In a very real sense, they were never separate from it to begin with. The boundaries of you, the skin that seems to define where you end and the world begins, that boundary is a useful fiction that biology constructed for purposes of survival. At the quantum level, there is no sharp boundary. There is just the continuous interacting field. I want to tell you about something called the path integral formulation of quantum mechanics, because I think about it a lot. It is a way of calculating what a particle will do, and it goes like this. Instead of saying the particle travels from point A to point B by a single definite path, you say it travels by all possible paths simultaneously. Every conceivable route from A to B, including the crazy ones that loop around Jupiter, all contribute to the final result. The particle kind of samples all of reality in arriving at its destination. Now most of those wild paths cancel each other out, and the classical path, the sensible one, is what dominates. But the other paths are real in the mathematics. They contribute, and I think there is something philosophically rich in that picture. Reality is not one narrow story. It is more like the sum over all stories, weighted by their probability. The ordinary story dominates because the universe is large and heavy and slow. But the other stories are there in the sum. Now the atoms that make you up. They have been on extraordinary paths. The calcium in your bones was manufactured by nucleosynthesis inside a red giant star approximately 5 billion years ago. It floated in a cloud of interstellar gas for millions of years. It became part of the solar nebula. It was incorporated into the early Earth. It cycled through oceans and geological processes. It became part of organisms. Eventually, some of it became part of you. When you put it that way, death seems like a very small event in a very long story. A change of configuration. A transition from one chapter to the next. Not an ending so much as a transformation. And here is something that I find genuinely moving, though I am cautious about sentiment in science because sentiment can lead you wrong. The information that you are, the specific pattern of connections in your brain, the memories and the knowledge and the personality, that is a very particular arrangement. And the second law of thermodynamics suggests that specific arrangements are very fragile. They are unlikely states. The universe does not easily put complex patterns back together once they have dispersed. So your particular pattern, the specific you, that is probably genuinely irreplaceable in any practical sense. That is worth being thoughtful about. Not depressing, just worth thinking about clearly. But there is another way to think about information. In physics, there is a famous principle associated with black holes and with a physicist named Bekenstein and later with Hawking and others. The principle says that information is not destroyed, even in a black hole. The information about what fell into the black hole is preserved, encoded, scrambled, but not deleted. This is actually a serious active area of physics called the black hole information paradox. And the prevailing view is that information is fundamentally conserved in nature, which means that the information that constitutes you, scrambled and dispersed though it may become, is not simply erased. It is redistributed, encoded in the positions and momenta of a vast number of particles in a form that is practically inaccessible but theoretically still there. I do not want to make more of that than it deserves. I am not saying you can be reconstructed. I am saying that at the deepest level of physics we understand, information is not simply deleted. That is interesting. What it means for consciousness or identity or the things people usually ask about when they ask about death, I genuinely do not know. Anyone who tells you they do know is beyond the boundary of what physics can currently say. Let me tell you something else about time, because I think it is important here. In physics, the fundamental equations are time symmetric. The laws of physics work exactly the same forwards and backwards in time. If you filmed a collision between two billiard balls and played the film in reverse, there would be no physical principle violated. The reverse process is just as lawful as the forward process. This is astonishing when you think about it, because our experience of time is completely one-directional. We remember the past, and not the future. We age in one direction. Things fall apart rather than assembling themselves. But the laws say both directions are equally valid. What makes time feel like it flows forward is entropy. The second law of thermodynamics is the one law that has a preferred direction. Entropy increases. And so our experience of time as an arrow pointing from past to future is really a consequence of the fact that the universe started in a very low entropy state and is moving toward higher entropy. But in the underlying physics, time is just another dimension. And in that timeless view, every moment of your life exists. Your birth and your death and every moment between them are equally real, embedded in the four-dimensional geometry of spacetime. The physicist Brian Greene talks about this. Einstein talked about it. The boundary between past and future, from the outside, from the God's eye view of physics, does not exist in the way it feels like it exists from inside the experience. In that picture, you do not go anywhere when you die. The moments of your life are permanent features of the structure of spacetime. They do not vanish. They are simply no longer in your future, which from inside the experience feels like loss, but from outside the experience simply looks like the geometry of a four-dimensional structure. I find that strange and beautiful and a little vertiginous. I think the honest thing to say is this. Physics gives you several things when you ask what happens when you die. It gives you conservation, the certainty that your matter and energy persist and transform but are not lost. It gives you scale, the vast sweep of time and space through which your constituent atoms will travel. It gives you symmetry, the deep time reversibility of the fundamental laws. It gives you the timeless block universe, the picture in which your life is a permanent structure in four-dimensional spacetime. And it gives you profound uncertainty about the hard problem of consciousness, about what it means for there to be experience at all, about whether that experience is somehow more than the atoms, or whether it is simply what certain arrangements of atoms feel like from the inside. What physics does not give you is the kind of comfort that people usually want. It does not tell you that your grandmother is somewhere waiting for you. It does not tell you that your personality will continue in some recognizable form. It gives you something stranger than that, and in my opinion, something more interesting. It tells you that you are made of the oldest stuff in the universe, that you are a temporary eddy in the flow of entropy, that you are a configuration of fields that arose once and will disperse and be reconfigured in ways we cannot predict. It tells you that in asking these questions, you are the universe investigating itself. And I find that honestly more moving than anything I have ever heard in a church. The atoms were here before you. They will be here after you. The laws they obey were operating 13.8 billion years ago, and they will operate 13.8 billion years from now. You are a pattern those atoms temporarily took. And for the brief time that pattern held together, it was capable of understanding, at least in part, the laws it was obeying. It was capable of music and mathematics and love and curiosity. The fact that such a thing is possible at all, that the laws of physics permit arrangements of matter that can contemplate those very laws, that is to me the deepest mystery and the deepest wonder. There is something else I want to say about complexity, because it bears directly on the question of what death is. You are not just a collection of atoms. You are a specific kind of information processing system. And I have spent a lot of time thinking about what that means. When light hits your eye, what actually happens is this. Photons, little packets of electromagnetic energy, are absorbed by molecules in your retina called photoreceptors. This causes a cascade of chemical reactions. Electrical signals travel down the optic nerve to the visual cortex. And somewhere in there, somehow, you see. You have an experience of redness or blueness or the face of someone you love. How? How does the electrochemical signal become the experience? Nobody knows. And I am not being coy when I say that. It is the hardest problem in all of science, harder than quantum gravity, harder than the origin of the universe. Because at least with those problems, we have some mathematical handles to grab onto. With consciousness, we barely know how to ask the question. But here's what we can say. The complexity required to generate that experience, whatever it is extraordinary. The human brain contains approximately 100 billion neurons. Each neuron connects to roughly 10,000 others. That gives you something like 1,000 trillion synaptic connections. And the pattern of activity across those connections is what you think of as yourself. Your memories, your personality, your sense of humor, your capacity for regret. All of it is in the pattern. And maintaining that pattern requires constant energy and constant activity. Stop the activity and the pattern dissolves. That is what dying is at the neural level. The pattern stops. Now, when I say the pattern stops, I mean the functional pattern, the one that was generating experience moment to moment. The atoms that implemented the pattern do not stop. They continue. But they no longer maintain the connections that gave rise to the functional organization we call a person. And this is genuinely different from the conservation laws, which tell us the matter persists. The matter persists. The organization dissolves. And which of those facts matters more to you depends on what you think you are. If you think you are your atoms, then death is nothing to worry about. Your atoms carry on indefinitely, but you almost certainly do not feel like you are your atoms. You feel like you are your continuity of experience, your memories, your sense of being the same person who woke up this morning that went to sleep last night. And that continuity is more fragile. It is a pattern maintained by ongoing biological processes. And when those processes stop, that particular continuity stops with them. But I want to push on this a little more, because the physics of it is actually quite subtle. You feel like you are continuous. But are you? Every night you lose consciousness. Every surgery under general anesthesia, you are gone, and then you come back. The person who wakes up remembers being the person who went under. The chain of memory is intact. But was there continuity of experience during the gap? It does not feel like it. So perhaps what we call personal continuity is really just a thread of memory and not a truly unbroken stream of experience. And if that is so, then death is perhaps not so different in kind from sleep. Just a longer gap, and one from which the particular chain of memory does not resume. The atoms, though, the atoms resume. They wake up, in a manner of speaking. They just wake up as other things. As soil bacteria that decompose organic matter. As the plants that absorb those nutrients. As the animals that eat those plants. The cycle is real, and it is ongoing, and your atoms are participants in it whether you think about it that way or not. You are a temporary local borrowing from the great commons of matter. You will return what you borrowed, and it will be used again, magnificently, in ways neither of us can predict. Now I want to say something about what I think the correct emotional response to all of this is, though I am aware that emotions are not exactly my area of expertise, and I want to be honest about that. When I look at the physics of what I am, what strikes me is not the fragility, but the improbability. The conditions required for a thing like me to exist, for a pattern of sufficient complexity to generate something like awareness, are extraordinarily specific. The constants of nature have to be in a narrow range. Stars have to form and explode and seed the galaxy with heavy elements. Planets have to form in the right place. Chemistry has to produce self-replicating molecules. Evolution has to proceed for billions of years. And then all of that has to produce a nervous system capable of asking why. The odds of any of it are vanishingly small. And yet here we are. Here you are, asking the question. That strikes me as something to feel grateful for rather than frightened by. And the fact that it ends. Well, feasts end. Conversations end. Sunsets end. And we do not usually think that the ending of them makes them not worth having. In fact, there is a real argument that endings give things meaning. That the temporal scarcity of a thing is part of what makes it precious. I am not sure the universe could maintain a pattern as complex as a conscious human being forever. Perhaps the second law makes that impossible in a finite universe with finite resources. Perhaps the impermanence is not a bug in the design, but a feature of the physics. Perhaps the only kind of universe that can contain things like us is also the kind of universe in which things like us are temporary. I do not know what happens when you die in the sense that you are asking. Nobody does. But I think if you look clearly at what physics says about matter and energy and time and information, the picture you get is not a picture of ending. It is a picture of transformation so complete and so vast that the word ending does not quite capture it. Something changes. Something profound changes. And what remains is part of everything that was there before you and everything that will come after. And that, in its own strange and impersonal way, is not nothing.